All right, thank you. My name is Charlie Wardman. I'm a soil fertility specialist based in Lincoln, Nebraska. And so, yeah, I was asked to address some of the agronomic issues associated with stock harvest. Some of the information that I'll be presenting is drawn from this NEB guide, which was revised last year, and so we think it's well up to date. There is a nice study going at South Central, quite a complex study, which gives us more information on harvesting crop residues as well as row of cover crop and nitrogen rates. Some of the information I'll be reporting is from some work that Tim Shaver, who is now at West Central Research and Extension Center, work that he did with his colleagues when still in Colorado. And then there are other recent UNL and ARS studies. So some of the topics that we need to be concerned about is the value of nutrients removed. And again, as this has been pointed out this morning, it's primarily an issue with baling and actually carrying it away as opposed to grazing. What are the concerns as far as erosion go, water and wind erosion, soil water availability, crop yield, soil organic matter, soil compaction, and then what might be some rows of cover crops or double cropping with forage crops and manure application. The first table in that NEB guide addresses the nutrients issues. So we have our column B, which gives typical concentrations of nitrogen, phosphate, potash, and sulfur, and crop residues, in this case corn, pounds per ton, and then you can put in a price for the nutrients and get your estimated value of the nutrients removed per ton. And when this was done in May of 2012, it came to $28.90 for the nutrients removed. In estimating how much crop residue there is, what we suggest is you use these guidelines, that it's about 1 ton for every 40 bushels of corn, 1 ton for 30 bushels of soybean, and for 20 bushels of wheat. So if we have a 200 bushel corn yield, we should have about 5 tons of crop residue. And throughout the NEB guide, or in the NEB guide, we do give more details on the nutrients, but about 17 pounds of nitrogen per ton of residue for corn, milo, and soybean, a little bit less for wheat, 3 to 4 pounds of phosphate, relatively more potash in the corn and milo as compared to the other crop residues, and some sulfur. So here we address erosion, and what we have on the left-hand column, the vertical column, the y-axis, is tons of crop residue that are needed to keep our erosion to less than 5 tons per acre. Now 5 tons per acre it's still a problem. It's not really unacceptable, but when we do have a serious problem, we like to see it brought down to that level at least by management practices. To get this data, we use Russell II, which is the NRCS tool for estimating erosion, sheet and rill erosion. We did it for Gage, Sherman, and Chase counties to capture a rainfall transect across the state, and we did it for 3 slopes. And the soils were silt loam or silty clay loam. And what we see, if we disc the red lines or have disking with terraces to gray, that for many situations we should not be removing any crop residues if we want to keep our erosion to less than 5 tons per acre. Even with 5% slope, there's a problem. If, on the other hand, we're doing no-till, the black lines, or no-till plus terraces, for all situations we can be doing some residue harvest. We see something similar for wind erosion, and to generate this figure we used the NRCS tool called the Wind Erosion Predictor. And again, we want to keep erosion to less than 5 tons per acre per year. And on the y-axis, again, we have crop residue, how much, many tons per acre should be left behind. And there we focused on western Nebraska, North Platte, Sidney, Scottsbluff, and we did the simulations for soil that's highly susceptible to wind erosion, medium and low susceptibility. Our tillage and cropping system choices, the red bars are no-till with continuous corn. The gray is no-till with wheat corn rotation. The yellow is, or cream colored is disc continuous corn, and the black is disc wheat corn rotation. And again, we see that for some situations, especially with the highly erodible soil, if we're disking, and it's continuous corn especially, that we should not be removing any crop residue. On the other hand, if we're doing no-till, and especially if we have wheat in the rotation, for all situations, we can be doing a considerable amount of removal without a problem. So we have situations like this. It was a rain-fed field in Frontier County. It looks like they cut the stalks and raked and really left the field bare. There was a lot of wind erosion in western Nebraska this year, and I would guess this is a field that was contributing to it. And when you consider the small amount of, residue they got, they must have been very to do this to this field. On the other hand, we have this irrigated field where we see quite a bit of the stalk growth. They didn't cut it, they raked it. They used the wheel rake, and they really controlled the down pressure on the wheels to minimize disturbance of the soil. And those standing stalks will do a lot to intercept the particles being moved by wind. And in addition to that, the aerial sowed winter rye around August 15th. They had one irrigation after that. And in November, it was in 100% cover, but there was quite a bit of cover to help stabilize the soil, protect. Here it was quite level, protect against wind erosion. That was his concern. But if we're sloping land, it would also give us protection against water erosion. So it's something, a lot, even on erodible land, if it's done right, quite a lot of stover can be removed. We know that crop residues help to conserve water, and Aaron mentioned this. It helps to reduce evaporation. If you have your stalk standing or straw standing, stubble standing, you get trapping of snow, and it helps to reduce runoff and increase infiltration. How much reduction in crop available water with stover removal? Well, in southeastern Nebraska, in some years it's probably zero because we get enough rainfall in the spring to recharge our water and pretty much have a full profile. But there's been at least one case where it's been measured that we lost 5 inches in western Nebraska. The difference with good cover as compared to where the residue removed was 5 inches of available water. So it is a concern. And soil organic matter. It's the key to having a productive soil, the physical properties, the chemical properties, as well as the microbial properties. We do know that it's the below ground biomass, the roots, the exudates from the roots, the microbial activity that we get there, that's most important to maintaining our soil organic matter. Much less so is what we have above ground. Important, but less important. And this is being well studied. These are sites of ARS throughout the country where they're looking at different aspects of this. And 5 of these we see are, quite close to Nebraska, including the one in Nebraska. The one in Nebraska is here at the RDC, and you've already heard some from Jim on this. One of the trials is rain-fed. It's on marginal soil. The other's on irrigated and highly productive soil. With the rain-fed site, like I said, it's rather marginal. It was eroded in the past, only 2% organic matter, which at least for this part of the state is low. Western Nebraska, it's not low. But there they found an increase in organic matter. The grayish blue bar is from 1998, and the maroon bars are from 2007. So at the 0 to 10 centimeter, or that is the 0 to 4 inch depth, we see that there was a gain in organic matter. But when we look at the full 5-foot depth, from 0 to 5 feet, we see it's a gain. So there, even with removal, they're getting a gain in organic matter. With the irrigated site, the organic matter, again, it's more productive to soil, greater than 3% organic matter. There they're comparing this to no-till, and they have 3 removal rates at approximately 0.40 and 80% removal. There they've seen a decrease in soil organic matter over 10 years for all treatments except the no-till treatment with no residue removal. So here they're producing much more biomass, but there is a loss. In the other study, they're producing less, but there is a gain. We don't fully understand this, but for high soil organic matter soils with irrigation, we do find that it is difficult to build organic matter. So again, I mentioned this before, but with residue removal and organic matter, we're concerned because the organic matter is important to chemical properties, soil physical properties, and microbial properties. In the NEB guide, we suggested that we should leave an average of at least 2 tons per year. Not necessarily every year, but on average over time, 2 tons per year, if erosion is not a problem. Some data to support this. This is from the study in Colorado that Tim Shaver was involved in. And here they're looking at water infiltration. The study was done under dryland conditions in Colorado. Productivity was not very high. And if we look at the x-axis, we have crop residue remaining total over 12 years. So this study had been gone on for 12 years, and some measurements were made on soil physical properties at the end of this. The 2 ton per acre rate is here. So quite low productivity, not much crop residue going back. Here we have absorptivity, which is an aspect of water infiltration. And when we have absorptivity of 0.3, that's equivalent to about 4/10 of an inch that can infiltrate in 25 minutes. It takes 25 minutes for 4/10 of an inch to infiltrate. Here we see the results presented in a linear manner. That is, as you increase the crop residue, infiltration improves. But if we look at this more closely, we see something of an increase in a plateau effect. That is, if we're maintaining, having about an average of 1.5 tons per hectare or per acre of crop residue out there, we don't have any more gain. So this is just suggesting, again, if we have our 2 tons per acre, we should be okay on infiltration. Here we have water-stable aggregates, and Aaron referred to this before. The aggregation is very important to water infiltration, resistance to erosion, both wind and water erosion. So on the x-axis, we have the total amount of the soil mass that's in water-stable aggregates. And we're only looking at the surface 1 inch here. So again, the data is presented here in a straight line fashion. But if we look at it a bit more closely, we see that we have a big increase with the first ton of soil crop residue that remains. But it continues to increase after that to above, or at least for the levels that they went. It could be that here at 2 tons, it's reached a plateau. So it's important to that, but it's suggesting that if we keep a minimum, or at least 2 tons per acre per year out there on average, we should be okay. Soil compaction, this is from the study that Aaron mentioned at Brule, Nebraska. We have the heavy grazing, the baling, the light grazing, and then no residue removal. And here it's the compaction only for the surface 1 inch. And we see that there was some effect that we have some compaction with the heavy grazing and the baling as compared to no residue removal. When they looked at deeper depths, it was only with the baling that they found the compaction as compared to no residue removal. So it's some effect, it's not a great effect. The question is it agronomically important? And as Aaron pointed out, there has not been a significant effect on yield. And actually the best observed yield over the years has been with the heavy grazing. Now, I should point out, this is a no-till situation. A lot of people will say that grazing and no-till are not compatible. Well, this suggests that there is not a problem with grazing and if you want to do no-till. Moving on to crop yields. Jim mentioned this. No, he mentioned the other study. This is the rainfed study here at the RDC. And these are the averages for 10 years of results. We have nitrogen rates, and we have different levels of stover removal. We see with the 60-pound nitrogen rate, it was not enough. Our yields are down, but the 120-pound rate was sufficient. No gain beyond that. With stover removal, we see at the low rate of nitrogen, that removal did hurt yield. So it's probably a nitrogen deficiency. That is, you're taking away nitrogen for 10 years continuous, and you're not putting much nitrogen on, and some yield loss. But with the 120-pound N rate, there was no yield loss. So what we're seeing here is if we're applying nitrogen at a reasonable rate, that we're not losing yield with stover removal. For this rain-fed situation, we're not gaining by doing it, but we did not lose yield. And these are the results that Jim presented. So we have our disc and no-till. We see somewhat better yields with the disking as compared to no-till. Now remember, this is continuous irrigated corn, so quite an accumulation of crop residue if we're not removing. We see for the disking that there is this yield increase with removal, and the increase is even greater with no-till, at least for that first increment of removal, that is removing 39–40% of the crop residue. These results are consistent with a lot of results that we see from the Corn Belt, that removing some of the crop residue, certainly for corn after corn, but even corn after soybean for high yield situations, very often does result in increased yields. On average, the yields are increased. This is the study that Aaron or Jim referred to this morning. Again, it's a no-till situation, grazing on no-till. And it continued for 17 years. And what we see for the soybean yield, soybean being a crop that followed the grazed corn, very little effect on yield and certainly no yield loss due to grazing. And then corn was that came the year after the grazing, and we see no effect there as well. So with the evidence available to us, it does show that no-till and grazing are compatible and maybe even favorable to yields. Manure application, and it is, you know, with feedlots, of course, manure does get applied. It supplies nutrients. It removes some of those removed nutrients, but we also know it's very good at improving that the water-stable aggregates and improving resistance to erosion. Cover crops and double cropping with forage crops can be valuable in reducing wind and water erosion and may contribute to soil organic matter. One question that we've started to address this year is, can we get by with less nitrogen if we remove stover? You know, if corn after soybean, we say we need less nitrogen than corn after corn. And we say the main reason for this is not because the soybean is giving us nitrogen, it's because the corn stalks are tying up nitrogen. It's causing immobilization. And so the question is, if we're removing some of that crop residue and reducing that potential for immobilization, should we be applying less nitrogen? And so we do have this study at 3 sites this year and plan to continue it next year, where we have 0 and 75% stover removal and 6 nitrogen rates, and we want to determine if those response curves will be different. 2 other studies that we hope to begin on farm this year are, one is, they're both double cropping of forages, and one is where, for seed corn producers, where they broadcast sow a brassica species like turnips into the corn when they take out the male rows in late July. And the corn is harvested early in those situations, often by the end of August or early September. Then it gives a lot of time for growth of the brassica, of the turnips. And so you put grazing animals on there, and the animals have both the stover as well as the brassica available, the top growth of the brassica as well as the root. And some farmers have had good experience with this, and we want to get better data on it. The other option that farmers have gained quite a bit of experience is drill sowing winter rye after corn silage. So again, you're doing it quite early, giving a time for growth. And in the trials we're planning is to look at the spring grazing by cows or cow-calf pairs. We're interested in determining effects on animal performance, the yield of the following crop, and that's very important, and the potential for nitrate leaching and depletion of soil water. So these are to be done on farm with sowing this late summer or early fall. So to recap, crop residue cover is important to erosion control. That needs to be probably our #1 concern. With the rain-fed situation here at the ARDC, there was an actual increase in soil organic matter, even with crop residue removal. But the irrigated site, on the other hand, we did not see that increase. There has been a decrease in crop residue removal, in soil organic matter, both with crop residue removal and without, with the exception of the no-till treatment. And the evidence is indicating that if we do leave the 2 tons per acre per year, it's generally adequate to maintain our soil productivity if erosion is controlled. In the Corn Belt, on average, looking at a large number of sites, there's been an increase in yield with residue removal. And from the ARDC study, we saw a small increase in soybean yield following grazing of corn stalks. There are exceptions, though, however. Western Nebraska, there has been a case of a research situation where there was a 30 bushel yield loss in a rain-fed situation by removing the crop residue. In Brule, Nebraska, on the other hand, with irrigation, we have not had any yield loss due to baling or grazing. Aaron mentioned these extension circulars, so I won't spend more time on them. And thank you. Is there time for questions or comments?